Let's look at second question of 2019. If the velocity of the particle p in moving along the x-axis is given by the differential function v of p basically is the velocity, and then measures the meters per hour. Okay, where t measures in hours. Select the value of v of p as shown in the table above. Okay, for particle p is at the origin at time t is equal to 0. All right, so let's look at this one together. Justify why there must be at least one time from here to here. So we're looking at these two locations where v prime of p, the acceleration of the particle, is equal to 0 meter per hour. So now, in this case, when you look at it, you have to notice these two values. Notice that they're the same. You see, what we have to do is average rate of change between these two, meaning v of p of 2.8 minus v of p of 0.3 over 2.8 minus 0.3. We know that to be our average rate of change, which is equal to 0, because 55 minus 55 is equal to 0. 0 over whatever becomes 0 anyway. And then, but the thing is, you have to realize by the Rolle's theorem, or by mean value theorem, given that it is continuous and differentiable function. So by mean value theorem, there exists C where v prime of p of c is equal to 0. So in order for you to use the mean value theorem, we have to talk about the functions continuous and differentiable. And that says right over here. All right, then let's look at part B. Part B is they want you to use a trapezoidal sum. So how'd you do it? Trapezoidal sum. So first component here, let me just erase this one first. There will be the first trapezoidal. And the second one is from here to here. And third one is from here to here, to approximate the value of the integral. So then first what we're going to be doing is 1/2 and base 1 plus base 2, which means 0 plus 55 times height, which is the difference between these two, 0.3, plus 1/2. But 1/2 is common in all of them, so I'm going to factor 1/2 out. Second trapezoidal is base 1 plus base 2. So you got to add up 55 plus negative 29. And then difference between these two, which is 1.4. That's the second trapezoid. Plus the third one between these two, so we get negative 29 plus 55. Difference between those two is 1.1. And you can put that into calculator. Then it will be equal to 40.75. That's what we can do here. Alrighty, then let's look at part C. The second particle Q also moves along the x-axis, so that its velocity from 0 to 4 is given by this one. Okay, that's fine. Find the time in the interval during which the velocity of the particle Q, which was given by here, is at least 60 meters per hour. And then find, so basically what we want to do is we want to sketch this one, and then we want to figure out this one is y sub 1, and then this one is y sub 2, and then we want to find out the intersection. So let's try to do that. Then I'm going to take out the calculator here. So we have 45 square root of x cosine of 0.063 x squared. All right, so that's basically what we end up getting. And second one is 60. Now, and then we are looking at the time 0 through 4. So what I'm going to do is I'm going to set the window from -1 to 5, maybe. And then I'm going to go for zoom fit. All right, so I see those two intersections here. So second, calc, find the intersection, number 5. That's the first one. Second one, that's near there anyway, guess. 1.866. So that's the first. So I'm going to call that as second quit. If I type in x, then that should be my intersection. And I'm going to store that as A. Alpha. So A value is that one. And then I'm going to go back to graph, and I want to find that the second intersection here. So second trace, number 5 intersect. That's the first one, that's the second one. Before you guess, you just have to go near the intersection. All right. 3.51. All right, so that's the second one. So I'm going to call that as B. So second quit. When I type in x, this time it's going to give me the second one because that's the value that I just got. Store that in alpha B. So now the B value is the second interval. Now, and then find the time interval. So they want us to find the time interval. That means t has to be greater than or equal to, I believe the earlier one was 1.866. And then second one is 3.519. Alrighty. And they want you to find the distance. Notice that it's a distance, not displacement. So then what we want to do, in order for you to figure out the distance, in this case it doesn't really matter because both of them are positive numbers. I mean the graph is always above, but in order for you to find the distance, what you actually have to do is you need to get the integral, math number 9, from A to B, because those are my boundaries. And that absolute value is what I'm looking for. Absolute value of y sub 1. Because distance is a integral of the speed, which is the absolute value of the velocity. Then you get 106.108 or 109. So to find the distance, 1.8662, 3.519, with the absolute value of the V cubed VQ of T dt, which is about 106.109 meters. So distance is traveled was this much. All right, so let's look at part D here. At time t is equal to 0, Q is at point x equals -90. All right, and using the result from part B, which was here, and then and the function v of q from part C approximate the distance between particle P and then Q at time t is equal to 2.8. So then what we're going to be doing is position, let me call that as x. So x of P, first particle, was about 40.75. Now, how do you calculate the particle of Q, location of Q? Since it started from -90, that's the initial condition, and then I need to see the change from 0 through 2.8 of the position. So what I'm going to do is I'm just going to get the V of Q T dt. So then what I'm going to do is, since I know the first value already, math number 9, and then it was from 0 to 2.8, and then it was y sub 1 and dx. But I need to subtract 90 to get the actual location. So 45.938. So when I do the subtraction, minus 40.75, then 5.18. So I get 5.188 is my difference in distance. All right, so that was number 2. See you at number 3.